Lesson 12, maximum and minimum problems. So the objective for this one is going to be to solve max min problems by writing quadratic functions that model the situations. We got to like come up with our own functions, and then we're going to be able to graph that and figure out what the maximum value is going to be. But I think the best way to do this is just to kind of like jump into it and show you how these questions work. So the first one says, find two positive numbers whose sum is 16. So just wait, sum means add, right? And whose product is a maximum. Okay, so what we're going to do is we're going to make two equations out of what we know here. And we're going to call the first number x. Could have called it anything, but we'll call it x. And we'll call the second number y. And what I'll do is go x plus y, because there's sum, adding them together, those two numbers, is equal to 16. So there, done. That's one question done. So we've got, so one of them is right there. The next one we're going to do is the second part here. It says whose product is a maximum. So maybe I'll put that over here. So product means to multiply. So we're going to say f of x is equal to x times y. So the reason why we did this f of x part is because we're saying this is the function, right? This function is equal to x times y. And we want to figure out where these two numbers are going to give the biggest number possible. A little preview of what's to come. What we're looking for is where, when we graph this function, we're saying, okay, where is this going to be the highest? We're looking for this. We're looking for a maximum there. But this isn't quite written in a form that we quite like yet, right? Because it has an x and a y. We don't really know how to graph that, right? You can't really put that in your calculator that nice. So what we need to do, that brings us back over to this equation. We need to figure out, we need to rearrange this so that this is going to say something in terms of x. What I mean by that is let's rewrite this expression with y is equal to, and then if we subtract x from both sides, we get 16 minus x, and that's going to be our rearranged version of this. So now I know that y is equal to 16 minus x. All right. Now, over here, let's rewrite this as f of x is equal to x, but instead of a y, I'm going to write 16 minus x, because that's what y is equal to. But now it's in terms of x, right? Now I can actually graph this thing because I've got, x in both of those. And this really is a quadratic equation, like quadratic equation just means that it has like an x squared, plus an x, or, but it has an x squared term. This does too, because if you expanded this, this is f of x is equal to, if we went x times 16 and x times negative x, this would be 16x minus x squared. And rearranging that is negative x squared plus 16x. So that is a quadratic equation, right? That should give us something that looks like this over here. So now that's the next step. So now we have a function. We need to graph it. So you can go ahead and throw that into your calculator. So that would be negative x squared plus 16x, and then enter. And then this is a problem though, right? Is that it looks like we got like a straight line, right? But I know it's not a straight line. It has an x squared term. We're probably just not zoomed out near far enough. So if I want to figure out how high I need to go, or how much I need to zoom out here, just if you kind of think about it for a second, this function f of x is equal to x times y, right? And those two numbers, x and y, they have a sum of 16. So if let's pretend like just for a second we put like an 8 in here, and we put like an 8 in there, right? Then that would be 64, right? So, oh, that was weird. It just disappeared. Anyway, that would be like 64. So I got a feeling we got to be up around at least 64. So what I would do is go menu, window zoom, window settings, and then I'd make my y maximum. Instead of 64, let's make it like 80. And then my x max, Well, let's make it quite a bit bigger too. Let's make it like 82. Okay, so 80 was too far on my x, obviously. So let's go back to like 30. So x max. Let's go 30. There. So that's pretty good, right? We can actually see this whole thing now, right? So now, if we want to figure out what those two numbers are going to be at the maximum, then our y here, right? This is what the numbers are going to multiply to, right? That's what's going up and down. And our x value, well, that's actually x. That's our x right there. So if we figure out our vertex, well, let's do it. I'll show you. So if we figure out our vertex here, so analyze graph, I want to figure out what the maximum is. I'm going to click to the left of it. I'm going to click to the right of it. And it says that my vertex is at 8, 64. Okay, so I kind of drew just kind of what we're dealing with here. We had 8, 64. So now just make sure we know what these numbers mean. This 8, that's the x value at the vertex, right? This is the y value at the vertex. So this is saying that this number, x, that's 8, right? That's our x value. Our y in this case, that's what they multiply to. That's our function, f of x. So when x is 8, then it would multiply to 64. So that's what the y value there. Sorry, I shouldn't say y value, say f of x, because we called this y over there. So that's going to be what they multiply to. That's f of x. Okay, now if we want to figure out what y is, we go back up to here now. Or what the other number was, right? We go back up to here, and all we got to do then is just go, okay, y is going to be equal to 16 minus, and we said x was 8, so 16 minus 8. So y was also equal to 8. So x was also equal to 8. So those were the two numbers. So that's how you solve those. The other way of doing this is going to be without graphing. What we could do, we could figure out the vertex by putting it into vertex form. So if we start out from this point here, let's rewrite that. Okay, so to solve without graphing, I'm going to write my function again. I want to figure out what the vertex is on this thing. So it's going to be negative x squared plus 16x. And then what I'm going to do is we need to complete the square. So let's rewrite this thing as I'm going to factor out a negative, and I got x squared plus, or sorry, no, not plus, minus now, minus 16x. I'm going to leave a space, and just so it looks like what we've been doing, you can call that plus 0 if you wanted to. Okay, now underneath this, we're going to have f of x is equal to, still a negative there, and we've got half of negative 16 is negative 8, so it's going to be x minus 8 squared. And then what goes in here? Well, that's going to be negative 8 squared, so that's going to be positive 64. But remember now, we didn't just introduce 64, positive 64. We really introduced negative 64, right? Because that negative up front is being multiplied by all the stuff inside. So we introduced negative 64. So we can't just go around introducing negative 64, so we also need to add 64. So this would be plus 64. So now that it's written in vertex format like that, I can see that my vertex is at v is going to be 8, 64. So same thing as graphing. Now I can just see that right from my vertex form. And then from that I can be like, okay, yeah, x is equal to 8. And then we could have figured out what y was equal to from our equation up here as well. Okay, so those are the two ways that you can solve these types of problems. One thing to notice too that I kind of forgot when we were up here, notice that we've got a negative out front of our x squared. That makes sense, right? Because if it's negative, then it's like a frowny face, right? And it's opening down. So that would give you a maximum value if it was opening down. Okay. So I'm going to let you guys go ahead and do number 2 on your own. Just notice it says difference. So your first, it's going to be similar to this one, but you're going to be subtracting the numbers to begin with. And yeah, that's pretty much the only difference. Okay, number 3. I'm going to let you guys do number 3 as well, because I'm going to do number 4. It's a little bit tougher, so you guys can go back and kind of do that. So number 4. A farmer wants to fence a rectangular enclosure for his horses and then divide it into thirds with fences parallel to one side of the rectangle. If he has 2,000 meters of fencing, find the area of the largest rectangle that can be enclosed. Should have been a T there. Okay, so let's draw a picture here first. So he wants to make a rectangular fence, right? And he's going to divide it into thirds, so there and there. And all of this length needs to add up to 200 meters because that's how much fencing he has, right? So what we're going to do is we're going to call this side of this fenced enclosure, we're going to call this X. So that's going to be X. We are going to call the bottom side, we're going to call that length Y. And that's going to be, we're going to be able to figure out what those two lengths are, right? So our formula is going to change a little bit though, because I can see that in this I've got two Y's, right? Because the top is also the same length as the bottom, right? So we've got Y on the top, Y on the bottom. And then I've also got these lengths here that are all the same. That's X. There's 4 different X's. So equation number 1 that we're going to make is going to be 4X and then plus 2Y is equal to 200, or 2,000, sorry. 2,000. Okay, so that's equation number 1. Now for equation number 2, it says find the area of the largest rectangle. So the area, looking at this picture over here, is going to be just X times Y, right? Just length times width. So let's write our function. It's going to be the same as it was above. It's going to be... And I could write f of x like we're doing. That just means like function of x. But what you might see a lot of times now is like certain letters being used. So a of x, just meaning area as a function of x. And that we're going to say area as a function is equal to x times y. But I don't like having 2 different values in my function, right? It doesn't really make much sense to put that in your calculator that way. So what we need to do is figure out what y is in terms of x. So let's go back up here and see if we can rewrite this expression with y is equal to. So let's say we're going to subtract 4x from both sides, so minus 4x. And I've got 2y is equal to 2,000 minus 4x, and then y is equal to 2,000 minus 4x divided by 2. Now, 2,000 and 4 can both be divided by 2, right? Both those terms can. So let's do one more step to make it a little bit simpler and say 1,000 minus 2x. So now I don't have anything in the denominator. It makes it a little bit easier. So now that I know this, let's put that into our equation. So now this is going to be a of x, the area of these two different varying values, is going to be x times 1,000 minus 2x. So now we're pretty much there, right? We just need to be able to find the vertex. We got, again, this is going to make a parabola, and so we just need to graph it. You can actually graph this thing in your calculator just like this. It doesn't. You don't need to expand it first like we did in the question above. You could put it in your calculator just like this, but I just gotta. I'll show you what I mean. So, okay. So if you grab your calculator and you put this in, we're gonna have x, and then if you go bracket 1,000 minus 2x, and then go okay, that's good. It's gonna say no, can't do it. It's gonna give you an error. But I just told you that you could. The problem with this stupid thing is that it doesn't know when I don't know if you can see that if it's too small, but I've got x and then bracket 1,000 minus 2x. I need to put multiply in there. It doesn't. It should just know that I want to multiply it, but it doesn't. So you have to push the multiply symbol in between. And now that I've done that, now it'll give me my graph. And it's going to be really, it's going actually straight up and down right now, it looks like, from, because I'm zoomed in so far. So what we got to do is figure out like what's a reasonable value that I can start with here. Well, if we think about like a reasonable place to start here, these sides, 4 x's and 2 y's, all add up to 2,000, right? So, you know, x here, this might be like, you know, 300 or something, right? And this could be like, I don't know, like 500. So to get off to like a good start, what if we went like, you know, 300 times 500? So yeah, 300 times like 500, let's say. You know, just kind of, this isn't like an exact thing, right? You're just gonna ballpark it, like, so you can get like somewhat close. Because then if you're a little bit off, you can like be, okay, I was a little short, and then just add whatever you need to it. So to figure out our window here, 300 times 500, so like 150,000 is what we're thinking. So let's go menu. Oh, and I changed my calculator too, so hopefully you can see it a little bit better. X maximum. So we're at 6, and we need to go like to 150,000. That makes sense why it looks like it's straight up and down, right? So 150, and then 1, 2, 3 zeros. And then X, remember we kind of said, well, what about like 500, right? On maybe 800, whatever you kind of think. I'll do 500 for now and see how that works. And push OK. And it actually worked out pretty good. Okay, so now we can see the top of our graph. So now we just need to go menu, analyze graph. This is a maximum we're looking for. So we're going to the left of it. We're going to the right of it. And it says 250, comma, and then 1.2 e positive 5. I'll explain what that means if you don't know. So first off, let's look at the 250 though. That's my x value, right? That is this. That's saying that x in this case is going to be 250. This is my area, right? This was a function that was telling me my area. That's what this was of, x times y. So this is my answer right there, but let's just make sure you know what that means. 1.25 e positive 5. So it's saying the area is 1.25, and it gave the symbol e positive 5. Well, what that means is 1.25. This symbol e is quite often used on calculators to mean times 10 to the 5. So that's what this is really saying, 1.25 times 10 to the 5. So times 10 to the 5 would mean that you'd move the decimal place over here 5 times if you wanted to figure out what that number actually was, what it'll actually look like. So that would be 125. This moved over 1, 2, 3, 4, 5 times. So there'd be 3 more zeros. That's what it would be. It would be 125,000. That's the same as 1.25 times 10 to the 5. And finally, you should probably have units here. This was we were measuring everything in meters. So this would be meters squared for area. So again, you could have also completed the square on this one if you wanted to figure it out that way. Might have been a little bit tougher with like the, no, it wouldn't be too bad. Yeah, but you could have done that as well. Just so look at the question above to see that example. Okay, so I'm going to end that video there because these next ones are going to be a certain type of max-min problems, like a revenue max-min problem. I'd just like to have that in its own video so you can refer to that a little bit easier. So that's going to be it for that one. Make sure you guys do those other questions. I'll make a video when you're done to make sure that you did them correctly. Yeah, I'll see you in the next video.